and migrate your existing workloads sits in the ability to implement each of these open source databases as a platform as a service, which will allow you to take full advantage of the Azure capabilities. By leveraging these Azure features, such as local or geo redundancy, you can really build data application and solutions at scale at a low cost and take advantage of industry-leading security and compliance features such as the advanced threat protection. The strong integration of Azure SQL DB for MySQL within the Azure ecosystem allows you to build your applications faster and build innovative solutions you can safeguard by using the Azure IP advantage. Let's have a look at these migration benefits and what these bring you. So customers don't use databases, they use applications, and the Azure database services are deeply integrated with the Azure services such as web apps, which provide a streamlined provisioning and management experience for the most common open source frameworks and languages used in MySQL today. Azure Database Services MySQL is a unique public cloud managed open source database offering in which we provide 99.99% SLA on all pricing tiers at no additional cost to you, the customers. This is achieved through the unique architecture of Azure Database Services platform that enables bringing up new database servers in the event of a server fail, or in the event of disaster recovery when needed. When we think about security, protecting your innovation in the cloud, reducing risk, and innovate with competence, operating with freedom in the cloud, Azure IP Advantage provide the industry most comprehensive protections against IP risk. We'll do that by implementing control access using secure SLS servers, firewall rules, and VNets, but also by implementing built-in encryption for data at rest or backup in motion and at rest. The Azure offering for MySQL, of course, is following the leading compliance offerings such as SOC compliance, ISO compliance, and meets all the regulatory requirements such as HIPAA. Azure Database for MySQL automatically creates server backups, so it's a built-in backup and restore capability, and store them in user-configured locally redundant or geo-redundant storage, being able and give you an opportunity to restore to a point in time. Monitoring the data about your servers helps you to troubleshoot and optimize your workloads. And we have many options available for monitoring or providing insights into the behavior of your servers. Azure Database for MySQL provides various metrics that give you the insights into the behavior of the resources supporting the MySQL servers. Each of these metrics is emitted at a 1-minute frequency and has up to 93 days of history. And you could fully configure these alerts and metrics for step-by-step guidance on how to set up alerts. We'll point you out to some additional resources that you'll be able to leverage as part of that. Now, query performance insights will help you to quickly identify what your longest running queries are. So it's very easy as a database administrator to identify those, how they change over time, and what weights are affecting them. The advanced threat protection capabilities detects anomalies within database activities, which might indicate potential security threats, such as injection attacks. And the new layer of security enables you to detect and respond to these potential threats as they occur by providing security alerts or anomalous database activity. The advanced threat protection makes it actually really simple to address using the Azure for Database Servers integration within the Azure Security Center all up without needing to be a security expert. For application developers, the Azure integration provides key integration with popular frameworks like Drupal, Django, but also popular programming language like Python and so on. We've done work to really make it simple for application developers to both provision applications on open source databases by building a connection in Azure App Services or with other services on Azure. Several of our customers have interesting solutions built around this, being able to leverage advanced analytics and AI capabilities as part of their broader solution architecture and scenario. Customers build these solutions with Azure Database for MySQL while taking advantage of the Azure global reach of 60 plus Azure regions where they could spin these services up and bring them closer to the users. Needless to say that this is one of the core reasons that customers want to migrate from on-premises or private cloud environments to Azure and taking advantage of the Azure Database Migration Service to be able to do online migration to Azure without the application taking any downtime. And we have a closer look on how that actually works as part of our migration steps. Now, when we think about the guidance on performing migrations, we actually built a very comprehensive database migration guide that is available for you to identify the path or the recommendation to drive the data migration forward. So the database migration guide allows you to pick and choose what's the migration strategy that we'll be using, from what source to the other, and will then access and give you insights into the right steps and the right points as part of the migration. Now, when we think about migration, there's a lot of aspects you have to consider prior to starting a migration. What are my databases? What are the database assets? What are the applications and environments that I have to go configure and assess whether or not the workload is suitable to perform the database migration to Azure. So we can assess these workloads and picks and recommendations, do an assessment of the source schema and see if that source schema will actually work in the target platform the way it sits in Azure. This is certainly relevant when you want to do subsets of your migrations or really make this shift from this on-premises environment, starting to leverage some of the new capabilities, or certain compatibility issues might arise. As we look at the actual migration phase, where you're migrating the schema and the database objects from the source schema and source database over to the cloud, we're going to be talking about some of the tooling that we're going to be using to perform that actual migration in real time or in an offline scenario. But we'll also look on how to sync your target schema and the data with the source, which is relevant and needed if you're using a minimal downtime migration strategy. And then at some point, you're going to have to do that cutover where you're going to be taking this application, this workload over to the new environment. Now, moving over from an on-premises environment and starting to leverage the past capabilities that we have with the MySQL offering, we actually have some great opportunity to start optimizing the destination environment. And we could do that by using the performance optimization, testing, do some validations around these performance issues. And of course, this is a circle of continuous optimization and improvement that is very common in some of these scenarios. How do you remediate applications? How do you run performance testing? And really, how do you optimize? So let's have a look in a bit more detail on what that migration flow will be. First of all, on your source MySQL instance and database, you're going to be configuring and preparing the MySQL environment to then move over. And there's quite some due diligence that you want to do that needs to be performed. This includes analyzing the data, look at your hosting environment and application workloads, and then validate whether this and what the landing zone on Azure is going to be. So one of the steps that we'll be doing first is provision the Azure destination, which is the target landing zone environment, is the final resting place of your cloud migration project. We could deploy and really configure this destination environment by using the Azure portal and manually provision, but it's actually not uncommon that this gets scripted using Azure Resource Manager or Azure CLI to spin up that destination environment. During your migration assessment, you would already have determined and planned which phase of migration or which approach to migration you're going to have, whether you'll be using a migration in an offline fashion or using a migration online for the minimum downtime. So one of the tools we'll be using around that is the Azure Database Migration Service, which facilitates the online migration of MySQL to Azure DB for MySQL, supporting multiple versions of MySQL 5.6, 8.0, but you could also migrate AWS RDS MySQL workloads to Azure DB for MySQL. That can be done online from an on-premises MySQL installation, or it can be done using an offline fashion as well. In the online scenario, the migration service copies all the source data over to Azure and then continually performs synchronization between your source and destination database. Any of the transactions that are performed against the on-premises system will be copied to the new database in Azure, and this process continues until you've reconfigured your client applications to then use the new database in Azure. You then would terminate the synchronization operation and move it over and start optimizing. Now, when we perform an offline migration, the option that we have there is to actually export the source schema, import it to the destination, or another common method that could be used would be to dump it and restore the data. We'll have a closer look on that in one of the next slides coming up. Now, as we provision the MySQL environment, you really will be selecting what's the Azure database for MySQL deployment. One of the initial steps is to go provision that environment. You could create that instance, as mentioned, by using the Azure database for MySQL, Azure CLI command, which is AZ MySQL Server create command, which at that point will be configured and spin up the destination environment. During the creation of the server instance, you then decide which deployment option you want to accomplish or achieve. And there's two options that we have in that space. You could go for single server, which is a fully managed database service with minimal requirements for customization of the database. It's designed to handle most of your database management functions, such as patching, backups, high availability, security, minimal user configuration and control, because it's all fully managed on the Azure side using the servers. So the single server is actually the best suited for cloud-native applications designed to handle automated patching without the need for granular control that typically have been managed by a database administrator. Now, what else you could do is you can decide that you would like to deploy a flexible server option. The flexible server option is really giving you more granular control with maximum control for the maintenance windows, high availability, zone redundancy, and so on. So there's a lot more fine-tuning and optimization you could do as part of flexible servers, a feature that is currently running in preview. So let's have a look on how we're going to be spinning that environment by provisioning an Azure DB for MySQL. On the Azure portal, if I want to find a specific service, I can actually type that straight into the search window and say Azure database for MySQL servers. What I can do now is, in order to add a new database for MySQL servers, I could just click and add, and here's what I have the option to specify what's the service plan that I would like to use, single server versus flexible servers. So as part of this demo, we're going to be setting up the destination environment and create the MySQL server environment using the PaaS service on Azure. As part of this demo, I'm going to be pointing out what my current subscription is, and we'll define whether or not I want to go create a new resource group. For the purpose of this demo, I will allocate these resources together into a resource group. As I create the new resource group, then I would specify the server details. And here's where you have the option to also configure whether or not you want to restore this from a previous backup. So my server name needs to be unique. So we'll specify here a unique server name. You'll see that an error will pop up if your server name is not meeting those requirements and the minimum amount of characters or special types be used. So let's call this server name I like MySQL on Azure as the name of my servers. and a validation is done and seems to be validated and fine. Next step I will specify would be the location of the server. So I'm going to put this server into the US East region. And I can then determine what the version of MySQL is that I would like to run. In this example, I'm going to be using the version 5.7. When you think about defining compute and storage, here's where you're going to be specifying how many CPU cores and what's the maximum storages that you could put as part of this MySQL server. Of course, you have the ability to look at a basic deployment, general purpose, or a memory optimized, which allows you to optimize up to 32 vCores, really giving you some high performance, predictable I/O performance over each of those cores. Of course, I have the granular capability to also identify storage and could specify whether or not they want to have storage options configured to automatically grow the storage. We'll have a closer look in the backup retention period, which by default is 7 days, which means the automated backup will be retained for 7 days, but I have the ability to expand that all the way to 35. Now, as we talked about the capabilities around the Azure platform, we also said we have the option to provide by default local redundancy, or we could do geo redundancy on that server as well, which allows us to do recovery from a regional outage or disaster if that were to be happening into a dedicated data center. For the purpose of this demo, I will just keep the defaults and click OK. Of course, I have to specify what's going to be my administrator account. So we'll do SQL admin. It actually gives you advice on what admin accounts cannot be used, and then we'll specify a password, confirm that password. Before we go to the additional settings. Now, on the additional settings, you have the possibility here to specify data encryption, and you also have the option to add a second layer of encryption, which is using a different, more complex encryption algorithm, and gives you the capability to actually provide infrastructure double encryption features. One of the things that you see happening quite common as well is that as part of the creation of the servers, you can set some specific tasks and tagging, which would actually be used in order for you to keep better track of reporting or keep better track of any additional resources. Think about if you're running this infrastructure for a larger environment or a larger enterprise, you might be able to do some dedicated tagging to the business unit or the business group that is taking use of this server. Now, prior to creating the servers, you'll have a full review of, hey, what are we accomplishing and what are we installing here? You have the view of the which subscription, what's the name of the resource group, what's going to be provisioned and your username and password. And what actually is really nice here at the bottom is you can download a template for automation. The moment you click on that automation option here, it will give you an Azure Resource Manager template that you can then use to do templatized deployments in the future, or you have the ability to just download it and then roll it out at any later stage in case you want to recreate or whatever you want to do after that instance is created. Now, spinning up this infrastructure is as simple as just hitting create. And my deployment at that point will be initialized, kick off the deployment process, and I have the ability to then go track the downloads and download the deployment details specifically from this deployment. As you can see, in this deployment of resources is occurring, you'll see that the resource, unlike MySQL on Azure, it's a MySQL deployment, has currently been accepted, and I can actually monitor the operation details of that as well, and look at the stage on what the process is and where it's running. You'll have this continuous refresh happening in your portal here that will keep track of the deployments. And once this is then deployed, of course, you will be able to configure that server connect, which then allows us to start doing the necessary initialization to consider the migration progress. So let's have a look back at the presentation and talk about these migration tools and capabilities that we have around this. So let's have a look at migration tools. One of the common tools we'll be using to perform migrations is Azure Migrate. Azure Migrate provides a central hub of tools to start, run, track, and analyze your migration journey to Azure. It's a free Microsoft service with the tools for each scenario available without any additional licensing cost. The Azure Migrate Hub integrates Azure services and partner solutions to maximize your options and your decisions. So if you want to perform a Windows Server and Linux migration, a SQL and non-SQL database migration, or a web app assessment and migration using App Migration Service, or a virtual desktop migration, or using a data migration using Databox, or performing holistic across VMware, Hyper-V physical server migrations to Azure, and whether or not this is an on-premises, an AWS, or a GCP migration, the Azure Migrate service will allow you to really bundle this all together as a unique migration platform, bundling and assessing your workloads, giving you these capabilities to perform all of these migrations with a single pane view of how these migrations work. Now, one of the other tools that integrates with Azure Migrate is the Database Migration Service, or DMS. When we think about DMS, again, we're talking about a service which enables you to perform large-scale database migrations from within the Azure portal, or integrate and combine some of the functionality of existing tools and services to provide you with a comprehensive, high available migration tools. The database migration service actually combines a set of database migration tools such as the Database Migration Assistant, SQL Server Migration Assistant, and the Data Experimentation Assistant. So you have a streamlined process of database migration in a single place, allowing you to perform database-sensitive migrations and move the data, the schema, and the object over to Azure. It's a very easy to understand process that will help you to get the done right, help you to get the job done right at the first time, with support for SQL Server migrations, MySQL, PostgreSQL, MongoDB, and Oracle migrations to Azure from on-premises and other clouds over into Azure. One of the other options when we think about MySQL migration is the ability to use data to perform a data migration using the MySQL Workbench. So that allows you to export and import data from source to target. So you would be able to download MySQL Workbench, install that on your operating system of choice to granularly select which tables you want to import, which database objects, whether or not you want to have specific views, stored procedures, constraints, and functions, and really granularly move those over. It actually is a very common scenario where some applications might just need to have a subset of the environment to be migrated and moved over. And you can migrate from not only use MySQL Workbench to migrate from your MySQL database, you actually would also be able to use this from text files and then use MySQL import to go add these tables into your database destination. So data import and export MySQL Workbench gives you that wizard-based UI to do a full or a partial export and import of individual database objects. One of the other options to perform a migration in an offline fashion is by using dump and restore. So dump and restore allows you to move an entire database. The tool is typically provided as part of the MySQL installation. It's a client utility that you can run to create local logical backups that could equate to a set of SQL statements, could be replayed or rebuilt database. MySQL dump would allow you to take this backup and restore that onto your destination. Core advantages of a dump and restore is you can actually prevent it from triggers firing during restores by using a parameter, which is the exclude trigger options. one of the common best practices when performing such migrations using dump and restore is you don't want those triggers to be refired on the destination database, and therefore that option could be used. Other options to specify there is in order for you to dump an entire database into a single transaction, you can specify the single transaction option and parameters. Which are some of the things you really need to consider when you're performing a dump and restore migration, especially if you're only using subsets of the data or subsets of the database. You would disable foreign key constraints as well, and you can actually defer index creation until the restore is completed, and as your database rebuilds by using the defer table index option. Now, as we talked about the tools that they have around migrations, let's have a look on how to perform an online migration using DNMS. So let's have a look on how to perform a migration from MySQL running on a Linux environment over to the Azure database from MySQL. While an offline migration often is a very logical migration strategy, the need to perform online migrations with a minimal downtime is often the preferred strategy by a lot of our customers. Let's start by taking an export to the database schema on the source server. We'll use MySQL dump to do so. So let's have a jump to the command line here and show you how that goes. So first we'll remote into that server. As we're logged in, we'll use MySQL dump. And we'll specify the database and the no data option, indicating that we just want the schema. There we go. Let's make a look. That file is actually there. And so we're ready to go. Next step, we'll copy over the script to the local drive, so that I can use that to then create a database and import the schema onto the Azure DB from MySQL. There we go. So as I indicated, prior to starting a migration project with the data migration service, we have to create a destination database, and then we'll import a schema. Of course, I can use a create SQL statement and add this to the existing schema creation. But what I can do is also want to show you some options and a variety of tools that you could use to create a database. In this case, we'll use Azure CLI, and let me show you how that works. There we go. So we use the AZ MySQL DB create, specify the name of the database, specify the name of the server, and then identify the resource group as well. And as you see, the output of this will now jump over to MySQL Workbench to run the script and deploy the schema. There we go. We're now connected. You can see in MySQL Workbench that I have that Adventure Work database that I just created in there. And what we'll do next is we'll open that SQL script. And we'll run this entire script. Okay, now once this database is created, we'll then jump over to the Azure portal and we'll create a migration project using the data migration service. So we'll switch to the resource group. And what I can do is we can go to Azure Database Migration Services and create a new service. So that would be as simple as just adding a new service, run through the wizard, specify resource group, what's the service name, the service mode and the pricing tiers, specify networking, and that gets provisions. We'll have a closer look on how that's done in the next module. I actually already created the Azure Database Migration Service. And so we can go straight to a new migration project. And it's in this migration project that we specify our source servers, connect to it, we specify our destination, and then perform the actual migration. So let's give that a name, specify what our source server is. We'll put the source server as Azure Database for MySQL. We want to perform an online data migration. And what we'll see here is that we do get some advice that says create a target Azure database for MySQL, deploy the schema, indexes, routines to the target database. You could use that using MySQL Workbench or MySQL then with no data to export the schema, then bring it in. But let's get to the next step and create this migration activity. So as I specified a source server here, we'll go to that virtual machine that we had deployed with MySQL installed on Linux, specify the user, and you see that there's validation that we can actually connect to the source server. What we'll do next is we'll put that target server specify the username for that as well. Make sure we have a password. And then we could select the source database and the destination databases. Now, what you'll see is that the database migration service actually allows you to bring over multiple databases at the same time, of course, under the condition that you already selected that source database and specified the target database in the destination. So automatically this will map and pre-populate. We can now go straight to the configure migration settings, in which we're going to be selecting the database objects from the source and then transfer those over to the destination. So I can expand the schema here. It will give me details on all the database objects. We could click next to get to the summary, and that will create an activity. So we'll call that MySQL migration run. And so we'll then kick off and start the migration. As we're running this migration, we can actually look at the runtime. We'll hit refresh here, so we'll see what our source service is, what our target server is as well. We could then look at the refresh. So we'll see that I'm going, in this case, from a source version MySQL 5.7 to the Azure database that I provisioned. I have a source database. The type of activity is an online migration. And we'll see that we're initiating and initializing the migration pipeline. We now see that this is running and that the data load is in progress. So we'll see that, hey, this is actually currently up and actively running. And that's how we perform the database migration using the online capabilities that we have. Clicking into the details, you'll then see that the database has done a full data load. If there were to be updates coming to the database, you'll see that will be reflected in the incremental data sync. So these tables are now in sync and will be synchronized until the moment you decide to cut over. After some testing and validation, probably the next thing you want to do is start the cut over. So that will take all the incoming transactions from the source database and stop them, and wait till all the pending transactions have been applied to the target database. At that time, pending changes counter will be reset to 0, and I can then redirect my application logic. So we'll click apply. And so then the only thing left for me to do will really be to redirect my application to the new destination by changing the connection string in the application. And looks like our migration is completed. Now, of course, next step is we can then start taking advantage of the capabilities that we have with this MySQL deployment. And so let's have a look at this Azure database from MySQL and look at some of the capabilities that we have here. Okay. At this point, I would actually be able to enable advanced threat protection, set up intelligence query performance monitoring, or set up read replicas on that server as well. And just to show you on how easy it is to actually to create a replica, I'll just specify the add replica feature here, and then indicate a server name and location. So we'll give that a name and say, this is I like MySQL on Azure 2. It validates the server name is available, and then I can specify any of the regions that are supported to set up a replica server. This is really a great way to bring your data closer to the users, having a read-only replica available for reporting purposes and so on. Okay, let's get back to the presentation. As we just completed our migration using database migration service, now let's have a look and think about some of these post-migration considerations. And one of the first considerations we need to have is related to business continuity and disaster recovery. By default, the 7-day backup retention was set as part of our deployment process, so I can go into the Azure portal and actually change that retention policy to 35 days. Now, one important thing to realize is that when we enable geo redundancy, you can only do this during server creation. So if you were to enable or need to enable geo redundancy post deployment, you would actually have to restore the servers, and at that point in time, you would be able to initiate geo redundancy as well. Now, one of the great features of the Azure database offering for MySQL is the ability to establish what we call read-only replicas. And the read replica feature allows you to replicate data from Azure SQL database for MySQL to a read-only server. you could replicate from the source servers to up to 5 replicas and really bring data closer to the users for some specific workloads. The replicas are updated using asynchronous MySQL engine's native binary log file position, which is a very common replication technology within the MySQL environment. So the replicas are new servers that you manage similar to regular Azure database for MySQL. And for each of the replicas you established, of course, you will be built for the provisional compute and vCore storage and usage. Now, this is a very common scenario in environments where you have read-heavy workloads that you could then eventually load balance, such as BI reporting, social media, web apps, and analytics. A very common scenario for you to explore post-migration. Now, as we talked about query performance and your ability to identify how well or how poor some of your database assets are performing, you could use a query performance insight tool that will help you to quickly identify what the longest running queries are, how to change them over time, and what weights are affecting them. This monitoring is directly established by setting up query performance insights, and you could look at the aggregation of results and view additional query output directly within the Azure portal by analyzing these workloads. We talked about the Azure performance capabilities and metrics using performance insights. What else you could do is you could also do performance recommendations directly within the Azure portal. And so the performance recommendation features analyzes your database to create customized suggestions for improved performance. So that means by enabling query store onto your server, you would fully utilize performance recommendations. And these performance recommendations will then come back to you and say, on these databases, on these database and tables and assets or objects, we discovered that, for example, you have a duplicate index. Why would you maintain a duplicate index, right? So it would be flagged as a high impact recommendation that you would then be able to identify using these performance recommendations. And at that point in time, decide to drop the index or follow some of the recommendations that were identified using these intelligent capabilities within the MySQL servers running as the SPAS service on Azure, and implement the recommendations just the way they are, or get some further analysis around that as well. In order to set up the advanced threat protection, as we discovered, the advanced threat protection detects anomalies in database activities such as potential security threats, which could be SQL injections, but you also have full control of really specifying access and which regions or which applications might be accessing your environment. So advanced threat protection makes it really simple to address some of these potential threats that you might have with Azure Database to MySQL, and integrates the alerts directly within the Azure Security Center. I hope in this session you had a really good grip and understanding of the capabilities that we're offering with the Azure DB for MySQL. And you can actually go ahead and start and find some additional details or get some hands-on on how to perform this migration. Now, some of this content we actually are covering as part of our Microsoft certification. And if you're looking to become certified, one of the recommendations that I have for you to look at as a database administrator is first start with the Microsoft Azure Database Fundamentals, which is available on our Microsoft Learn platform, or then pursue to achieve the Azure Database Administrator certification. So a lot of the materials that were covered as part of this presentation and this session is getting you a step closer towards these certification paths with additional content available on our Learn platform. With that, I want to thank you for your time and hope you enjoyed the presentation, and see you in the next one where we're drilling down into the PostgreSQL migrations. Thank you. Thanks for joining. We will now take a 10-minute break, see everyone back here, and then we'll discuss how to migrate PostgreSQL workloads to Azure.